through this. I'm going to make this really brief because I feel you guys don't need a whole bunch on this. If you've done bottoms up, then I'm not even going to do easy factoring. I'm just going to jump right to factoring something where A is not equal to 1, so the harder ones. So let's take an example. How about if we take...
Wait, can you like go through a bottoms up first? Because like I don't remember.
Yeah, I'm gonna do it right now. I'm gonna go through it.
Okay then.
I don't pay attention.
Okay, before I do this, let me remind you about something here too. Let's talk about factoring and how practical it is. As a calculus teacher, I can tell you it's important to be able to do. It's a big deal. But in reality, how often, now why do we factor things? Okay, we factor things because we're trying to solve a quadratic equation, right? We'll spend more time dealing with this next year, but you're already pretty well set, I think, to go through this quickly. So if we had something like, let's just say we had the equation 3x squared plus 3x equals negative 7x minus 8, something like that. If I want to solve this equation, what I do is I want to push everything to one side and put it into standard form, so it's set equal to 0, right? Which would be this. Everybody agree? Okay. I would have that equation. I'm taking this right. Yeah. Okay, so then, and now I would be solving, not factoring. If I'm solving this equation, I've got some different approaches to this. When it works, factoring is easy. Factoring utilizes what's called the zero product property. Okay? Remember what that is? Maybe not. Let's do, before we jump into this, let's just do a little mental arithmetic, a little warm-up. So don't write this down. I want you to do this all in your head. Okay? Just kind of keep following me. We're going to do a little arithmetic to warm up. So what is 3 times 11? Okay, you don't say it out loud, just kind of do it in your head. Minus 3 divided by 3. Keep going.
Are we going by MDAS or are we?
You're just going step by step. Just as I give you one, you just do that.
Okay.
So I'll start over again.
Oh my god.
What did I do? Oh, okay. 11 times 3. Get that answer. Minus 3. Divide by 3. Gotta keep going. I'm gonna really work it here. Times 7. Times 11.392.
Thank you.
Hang on a second. Divided by 1.3794. Okay. Times pi. Hang on. Hopefully you're with me. Times 0 equals
0.
0. Okay, there's my point.
Elton's like, I don't know, that's a 0.
Okay, my whole point is, if I string together a product of a bunch of things, if the answer is 0, what did I have to do to get to 0? If I'm multiplying stuff. I had to multiply by 0, right? So the zero product property just says if a product of factors equals 0, that can only happen when at least one of those factors equals 0. So our job here, if we can do this, if we can break this up into factors, whoops, you got that? Yeah, that was a little quite what I expected. Okay, so if we can write this as two factors, let's just call it A times B equals 0, then I know that can only happen if either A equals 0 or B equals 0, right? Does that make sense? So that's our motivation to factor something, so we can solve an equation. But it only works when factoring works. Factoring doesn't always work. If it doesn't work, we've got other options. Did you folks do the quadratic formula last year? Yes. So you did do the quadratic formula? Okay. Okay, raise your hand if you could, don't say it out loud. Raise your hand if you could tell me the whole quadratic formula.
Maybe.
You think you could?
I gotta write this down.
Not sure? Maybe?
Wasn't that
Isn't it like...
thing with like?
Yeah, there's a square.
Oh.
Okay, I'll tell you what, I am going to... It doesn't matter if you can or can't, because by the end of the period, you will never forget it again. We'll come back to that, but that's our next next line of defense. If we can't factor it easily, then we would resort to quadratic formula. But what we're working on here is trying to our goal is to try to see if we can factor it easily. And can we do that to solve this equation? Can we break this into factors? We'll see. The technique that you're going to use is a really good one called bottoms up, and here's how it goes. All you have to do is, first of all, if there is a greatest common factor, we need to extract that and pull it out. Is there a greatest common factor other than 1? No, there's not in this case, right? So we're stuck with the coefficients as they are. This is in the form, by the way, and hopefully this rings a bell. If it doesn't, it's no big deal. But this is in standard quadratic form, so it's in the form ax squared plus bx plus c equals 0, right? Does that ring a bell? So what's the value of a? B is? 10. C is? 8. Okay, so with bottoms up, and I'm going to put some resources on Moodle for this too. I will put a couple examples up there. In fact, I'll put these examples up there. I'll link to a video where it shows you how to do this, in case you forget. There'll be stuff there that'll remind you. So all we do for bottoms up is we're going to multiply, after we factored out the greatest common factor, we multiply a times c. Okay? So a times c in this case equals what? 24. Okay? Then we want to find, so that's kind of step 1 would be greatest common factor, but there wasn't one, right? Step 2 is we're going to find out what this number is. Step 3 is we want to find, if possible, if we can't do step 3, we can't factor it and we're done anyway. We just move on and use quadratic formula. Step 3 is we want to find the factors of this number of AC that add up to B. Are you remembering this?
Yeah.
So we want to find factors of 24 that add to 10. What would those be?
6 and 4.
6 and 4. Everybody agree?
Yes.
Okay, 6 plus 4 equals 10. So my numbers are 6 and 4. Okay? Then all we do is we're going to write our preliminary factors. So we're not done yet. Our preliminary factors are just going to be x plus 6 and x plus 4. Okay? If one of these numbers or both of them had been negative, that's fine. I just would have gotten x minus something and x minus. Does that make sense? So we're just adding these numbers to x. Okay, now the next step here in bottoms up is we've got to take our preliminary factors and we're going to divide by the leading coefficient a. Okay, we're going to divide these numbers by the leading coefficient a. So this transforms into x plus, 6, right. So we get x plus 6 over 3 and x plus 4 over 3. That just becomes 2, right? Okay. So this one just becomes x plus 2. So it's done. This one over here, though, does not simplify, right? And so if it doesn't simplify, the rule is we have to clear the fractions by multiplying through by whatever denominator is left over. What would it be in this case? 3. So we're going to multiply this one through by 3 times x plus 4 over 3. If I distribute the 3, what do I get? Yeah, I get x plus 2 and 3x plus 4. And that's my answer. Okay. Does that make sense?
Yeah.
How to get denominator of 3? Because that's the value of a.
Oh, so you plug in the A.
Yeah, just divide by a. Just divide both of those numbers by a and then simplify that. Let's do another one. Yep. Question.
I can't remember this, but what do we use those factors for?
Okay, so what do we use them for? Okay, so now we got them. Here's what we use them for. Come on. So good question. Glad you asked that. So here's our equation Now, what did that break up into? What were those factors? I had 3x plus 4 and x plus 2, right? Okay, now we apply the zero product property. So we know that the product of those two factors can only equal 0 when the individual factors equal 0, right? So what are the two possibilities? Either for this product to equal 0, either 3x plus 4 has to equal 0, or x plus 2 has to equal 0, right? So the whole point here is we traded one big ugly quadratic equation for some simple linear equations that we could solve in 1 or 2 steps. So what's the answer to the left one? Careful.
The left one is four.
So what are the 2 steps to get the x by itself? Okay, so subtract 4 and then divide by 3, so I get x equals negative 4/3. That's one solution. And then when is this one equal to 0? When x, that's why. Okay, now that we factored it, we can find out what the 2 solutions of our original equation are. Okay, how can we check them? Plug them in. They should give us 0. Okay? Make sense? Okay, let's do another one. Okay, try like this guy. So I don't just do the factor part. I don't care about the solving part. I just want you to use bottoms up to factor 5x squared minus 17x plus 6.
And this equals 0.
Well, I mean, if we were solving it, it would. You're right. But here we're going to ignore about the context and just work on just the factoring. Okay, we get an answer? Okay, what'd you get? X minus 3 and okay, let's go through it. Let's go through it. Yeah. Okay, so do you have something different?
Well, I just got the factors.
Oh, that's all I want you to do. Just get the factors.
Yeah.
We're just factoring. Yeah. Okay, so let's go through this. So are there any common factors here? What do you think? No common factors. So we can skip step 1. We don't have to factor anything out. So what's step 2?
Multiply A by C.
Okay, we have to find the product of A and C. So what's A times C? Whoops. Oh, broke. Okay, so what is A times C equals 30? And then I want to find what? Okay, I got to get my magic numbers, my preliminary numbers. I got to get the numbers that multiply to 30 and add to negative 17. So what would they be? Good. Negative 15 and negative 2. So those are my preliminary numbers. So I know that this is going to look like the product of x minus 15 and x minus 2. Now what? Okay, I've got to divide those numbers by the leading coefficient of 5 and simplify as much as I can. 15 over 5 reduces to negative 3. Good, so this becomes x minus 3. And then what about over here? I get x minus 5 halves, so I've got to distribute through what? A 5, okay. 5 times x minus 2/5 is?
Negative 5
5x minus 2. We could make that kind of easy though, couldn't we? We could always just say whatever this value is right here, we're just multiplying that by x, really, aren't we?
Yeah.
Agreed? Once this is reduced, okay? That's my answer. Okay? Make sense?
Yeah.
Okay, let's try one more and then I think we're done. Okay, factor this. what's the first step here before we jump into this?
Factor.
Okay, what's the greatest common factor?
3.
3. Okay, so we're gonna factor out that 3 and just leave it out there then. That's gonna be in the answer, right? The 3 is gonna be in the answer, and then we'll proceed with the rest of the question, rest of the problem, just like we did last example. So we can pull the 3 out front times what's left over. So now we have to tackle that one. Okay, next step. What was it again? 12 times 2, okay. So AC equals 12 times 2 is 24. Okay, you gotta be careful with this one. We wanna find numbers that multiply to 24 and add to, okay, add to what though? Okay, add to negative 11, so we get negative 8 and negative 3. Does that make sense? Negative times negative is positive, so it works, right? But they add to a negative. Everybody agree? Okay, so we end up then with x minus 8 times x minus 3. And what do I have to put in the denominators? 12. Okay, so we got to simplify those now, right? What does this one simplify to? And by the way, I really need to have this 3 out front also, right? Got it stuck out front. So what does this one simplify to? X minus 2/3, good. And this one simplifies to x minus 4. Okay, so what's this fraction going to, or what's this factor going to become then?
3x.
Good, 3x minus 2. Everybody see that? Just multiply that denominator times x after simplifying. That's our shortcut. And what's this one become? Okay, very good. Got it? I think you do.
And then do we multiply that last 3?
No, we want to leave it, when we're factoring, we're trying to break it apart as much as I can. So I want to leave that 3 out front. That's the greatest common factor.
I know that.
Okay? All right, I think we're done. Let's